Hi, welcome to chapter 2 on kinematics. Today we are going to learn about motion. What is motion? Okay, motion is a study of S, V, U, A, T. What is S? S represents distance or displacement. Okay, sometimes distance is called D. Okay, what is V and U? V means final velocity. U means initial velocity. So this one is V or U. Sometimes V or U also called speed. Okay, so they use quite loosely, but generally V is final velocity, U is initial velocity. What about A? A is acceleration and T is time. Okay, let's first take a look at what is distance. Distance is a total length travel. It's very simple concept. For example, if you are here, you move from X to Y, you travel this curved path here, and this curved path, the total length is 12 meters. We call this as distance. Okay, irrespective of direction, it doesn't care what is the direction of travel. If you move from here to here, okay, what is the distance travel? You just add up all this length, right? As simple as that. Okay, it is a scalar quantity and its unit is meter. Okay, simple. Now let's look at what is displacement. Displacement is a slightly more difficult concept because displacement is actually a vector quantity. A vector means what? Vector means has the magnitude and direction. Okay, there's magnitude and direction. So now what is so what is displacement actually? Displacement is actually the speed with direction. Do you understand? Okay, as simple as that. So it's not enough to talk about the speed, it must be talking about direction as well. So for example, let's look at this. If you move from X moving to here to Y, we say that the distance is 12, but what is displacement? Displacement is the linear distance, or is a straight line distance between the initial point and the final point. In this case, it is this length represents displacement and is in this direction. You see, you must tell people the length or the magnitude or the size of the quantity that you are measuring, as well as the direction, in this case to the right. Okay, so you must say the direction. The unit is still meter. Okay, they are vector, they are magnitude and direction. Okay, now, and since it has direction, if I assume this to the right as positive, then to the left it will be negative. If we treat outward as positive, then downward will be negative. If we treat this direction as positive, then this direction is negative. Okay, so it's just opposite direction, they have opposite sign. Displacement is a vector. It has positive, negative, and 0. Under what situation it will become 0? For example, if I start from here, then they move from here to here to here to here to here to here back to the same point. What is the distance? Obviously, distance is from here to here, all add up, right? Then what about displacement? Displacement will be 0. The S will be 0. Displacement 0. Why? Because the initial and final position, they are at the same point. In other words, there is no difference in distance between them, between the initial and the final point. If you have a ball here, move from here to here to here to here, then end at this position, where is the displacement? Where is the distance? The distance is from here to here to here, add up everything, right? Then the displacement is initial and final, the difference of length between them. Okay, this is called displacement S. Okay, let me test you one final one. Okay, see, for example, okay, this is a reference line, 0 displacement. Is let's say it is 0 displacement. Let's say I treat to the right as positive. Okay, now the ball move from here to here. Okay, this length, total length is 5 meter. Then then reverse direction, and go back to here. Then this is a let's say this distance is a 3 meter. So tell me, what is the displacement of the object? And what is the distance? Distance must be 5 plus 5 plus 3, 13 meter, right? What about displacement? Displacement must be this length, right? This is the initial, this is the final, this is the length. So what is this length? This length is 3 meters, right? This length is 3 meters. So what is the displacement? So you say, oh, displacement is 3 meters. Oh, well, you're wrong. It's not 3 meters. It's actually negative 3 meters, because I said already, this is displacement equal to 0 for this reference line here. Anything to the right, I already said as positive, right? So everything here is positive displacement. Anything here is negative displacement. If we return back to this same original line, the displacement is 0. Okay, let's just switch to the right as positive. Okay, to the right as positive. Now let's say initially start from here, the displacement is 0. So we treat to the right as positive. That means here all these are positive values, alright? So this starting point is displacement 0. So to the right is positive, so you move from here to here. So obviously, what is the displacement? The displacement is this and this one, right? Okay, so it's 2 kilometers to the right, positive. Huh? What if you move like that? What if you move backwards like that? So you know that this is s equals to 0, and we already said that to the right is positive. So we say this is the displacement. This initial, this final is to the left of the 0 displacement reference point. So we say this is negative 2. Okay, this length is 2. Now what if you move from here to here to here to here and back to the same point? The displacement there will be 0. Okay, because the initial and final point, they are the same. Alright, so in other words, remember, all the vectors has positive value, has negative values, and has 0. Okay, there are no third options. There are no fourth options, only 3 possibilities. Please take note.